Hi, AppSec engineers. Welcome to another video of security engineer interview questions. In this video, I'll be looking at the very important vulnerability question: what is insecure deserialization? Let's get started. We're going to be constantly putting out content on AppSec, cloud security, container security, DevSecOps, and Kubernetes security. Now, if you like this sort of content, you should consider liking and subscribing to this channel on YouTube. In addition, it would be great if you could follow us on Twitter and on LinkedIn. Ever since Insecure Deserialization appeared on the OWASP Top 10 in 2017, it's been one of the most talked about vulnerabilities of its class. In fact, Insecure Deserialization has led to some of the largest application security driven breaches the world has seen, especially things like the Equifax breach and so on. So you've seen a ton of these insecure deserialization breaches that have caused massive impacts to organizations and applications the world over. In this video, what we're going to be doing is we're going to be looking at a quick theory segment on insecure deserialization, and then we're going to be deploying a lab on AWS. So we're going to be deploying a serverless function on AWS that is vulnerable to insecure deserialization, and with that, we'll be exploiting that serverless function and doing a privilege escalation attack into that AWS account using insecure deserialization as the keystone vulnerability to gain access to that environment. So stay tuned. It's going to be a very exciting segment. I'm looking forward to the rest of it. So let's get started with what serialization and deserialization is. Now, most of us, especially if you're building apps, have probably done this quite extensively. This is a very common process of building apps when we serialize data and deserialize data. Now, serialization essentially refers to taking an object in memory and converting that into a stream of bytes. So imagine that you have an object in Python or in Node or in Java or in any other language. Now, you obviously want to send this across the network and have another system process this particular input and then use that input for something. So let's say you want to send this object to another application, and this application is going to use that object to do something with it. So in this case, obviously, you can't send that as a Python object or a Java object or a Node object. You'll need to convert this into a format or some kind of a structure that the other system understands. And that's essentially what serialization is. So when you take this object or this particular object in memory, convert that into a JSON object or an XML or any other type of serialized object, you have serialization. Or if you want to store it in the database, that's when you also have serialization as well. So serialization is a process of converting your objects to a stream of bytes that can be stored either on a file, pushed across the network, stored in the database, otherwise expressed in memory, or sent across the wire for other applications to deal with. Now, deserialization is a process when the other application receives this particular input. What the other application is going to do is it's going to deserialize this data, which means that it's going to convert this stream of bytes that you have back into an object that it can use to process something. So let's say you're going to create a user. Now, when you send a JSON structure or a JSON object of that particular user to a receiving system, the receiving system converts that JSON object back into a data structure or a Python object or a Node object or a Java object or whichever language of choice, and that would be used to create a user or store in a database or something like that. So when that object is deserialized back into the object structure, that's the process of deserialization. So serialization is a process of converting an object to a stream of bytes. Deserialization is essentially doing the reverse, converting a stream of bytes back into an object. Now this looks pretty straightforward. In fact, most of us have dealt with serialization formats. In fact, if you've used XML or JSON or YAML or TOML or any of these formats, you've successfully done serialization and deserialization. In fact, if you're dealing with a slightly older school application or a desktop type application, you might even be dealing with platform-specific serialization formats, like Java serializable or Python's pickle format or PHP serialized format. Now, these are specifically platform-specific formats, but you also have a lot of platform-agnostic formats like XML. XML can be processed or read by any system or parsed by any system or generated by any system or any platform or language. Same with JSON, same with YAML, same with TOML. So you will see that there are two types of serialization formats, something that is platform-agnostic that can be used with a multitude of different languages and platforms, and some that are platform specific. That's essentially what serialization and deserialization is all about. Now, deserialization occurs, or insecure deserialization really occurs, when the attacker embeds some kind of malicious code in the serialized object and sends it across the wire or stores it in a database that your victim application tries to deserialize or unmarshal. So when the unmarshalling happens, which is essentially the process of deserialization, this particular payload does something, and that something could cause a security event in the target application. So realistically, if you look at the most common realistic example of a deserialization attack, it would be like an attacker mailing a bomb in a package and sending that in the mail to somebody, and that somebody receiving this, just opening it up, and then the bomb goes off, causing all kinds of bad things to happen, obviously. Now, deserialization is very similar. What the attacker really wants to do in most cases with a deserialization attack is to perform a remote code execution attack. Now, we've seen this with several other flaws. We've seen this with SQL injection. We've seen this with template injection. The attacker wants to run their code in your target environment, and that's really one of the major intentions of the attacker doing deserialization. So there are usually two reasons why an attacker would use deserialization. One is to do remote code execution, where they want to execute their code on your environment or your target machine, or to bypass permission. So a lot of times you will have serialization formats that have the user role or the user type embedded in the serialization format. So let's say you have a Ruby data structure that captures the user's data as a user. Now let's say the attacker tampers with that and changes the user to admin and sends it across the wire. The attacker may be able to leverage elevation of privilege attack to gain access as an administrator to that particular application. So usually there are two reasons why an attacker would do something like this, but usually in most cases, the primary reason why the attacker would want to do a deserialization attack or leverage a deserialization attack is to perform remote code execution. So now that we have an understanding of what insecure deserialization is, let's look at a specific vulnerability and, of course, leveraging this vulnerability in a cloud environment as part of our lab, which is going to come up next. So we are going to be using a lab which is based on a library called PyYAML. So PyYAML is a very heavily used library which, as you can probably realize, as the name suggests, it essentially is used to parse and process YAML. Now, PyYAML has this, or at least at version 3 of PyYAML had this very dangerous functionality, is that when you try to load or parse a YAML, and if that parsed or if that YAML file essentially had some kind of object code or some Python source code, it would essentially execute that Python source code like an eval or something like that. So obviously it's super dangerous, because imagine your application is processing YAML from multiple locations or multiple sources, and if one YAML contains some kind of object code or some source code that needs to be run, that typically would be a extremely dangerous thing, because that means that code is running on the target machine server side, and as a result the attacker could do remote code execution. So let's look at this vulnerability with PyYAML and see how dangerous it can be, especially in a cloud environment, because we're going to leverage the same flaw to be able to gain access to the cloud environment and then perform some kind of lateral movement or privilege escalation with this vulnerability. So let's get started with our lab on privilege escalation with the PyYAML insecure deserialization. So this lab is probably going to expose you to one of the most dangerous sort of serverless attacks that I can think of. So I'm going to talk about this, and I want you to be a little extra careful with this lab and deactivate it immediately after you're done with this lab. So it's an intentionally vulnerable serverless function that we're going to deploy right now. And this serverless function can be really dangerous if you leave it running. So one of the things I have to say before we get started with this lab. As soon as it's done, please remove the lab. Now, this is where we're going to look at remote code execution flaw, something that we've already spoken about, the insecure deserialization flaw. If you've not looked at what insecure deserialization is, please look at the previous video on insecure deserialization. It explains what it is and how it works. In this case, we're going to take up an app. We're going to deploy a vulnerable serverless function that is vulnerable to insecure deserialization, where we're going to upload a YAML. And this YAML essentially is going to be processed by our serverless function, which is vulnerable to a YAML deserialization flaw. Now, in this flaw, the way it works is that in the YAML, if we essentially try and load some Python object code, it will load that Python object code, which in this case, it's going to actually execute a backend operating system command. Now, remember, just because a Lambda is considered serverless doesn't mean there are no servers. There actually is a computing environment in the background, and we're going to try and access some of these variables from that computing environment and then try and compromise the entire Lambda function, and from there try and escalate privileges to the AWS account. So that's what we're going to try and do in this example. So just to make this function a little bit more secure, we've added something called a secret key, and I'll explain how that works. So the first thing I'm going to do is generate the secret key. Now let's export this. If we export this secret key, you should see that we should have some secret. So this is going to be added as an authentication factor for this lab, but I still recommend you delete the function as you're done with it. So we're going to authenticate with this secret key, and we're going to the serverless function. I'm going to install the serverless function. Now let's look at what's happening here. Let's look at the YAML file for the serverless function. Now here you'll see that we're deploying a function here, which is in the handler file, which is the main function of Handler.py. This is just allowing us to upload and process a YAML. So it's essentially going to allow us to upload a YAML file, and it's going to allow us to process the YAML file and just echo the response from that processed YAML as JSON. So if you look at the handler, you'll see that it's just allowing us to upload it and then processes the content and then generates a response with the processed content as base64 encoded data. That's really it. That's really what it's doing. The idea here is to just demonstrate what can happen if you have a remote code execution flaw on your Lambda environment. This is just a demonstration. This is just going to give you an idea of what can happen. This can be substituted for any remote code execution flaw, and you can have this kind of an outcome. Somebody can completely compromise your Lambda function, and through that gain access to your AWS account. So you can see that there are a few things we're doing wrong. You'll see that we have star privileges on multiple resource types. So EC2, we have star, which means that if I am able to compromise the token from this Lambda function, I can now start to even run EC2 servers on my AWS environment. So you can see that this is very, very dangerous. If these privileges are compromised, then if this token is compromised, then you have a lot of privileges on EC2, you have a lot of privileges on S3, you can do pretty much a lot of that stuff. So we're going to deploy this serverless function. We're going to deploy it, and I'm going to be fast forwarding through the deployment. So what we just did now was install the Python plugin, which installs the Python requirements, the Python dependencies that this function needs. It only needs one library, which is the PyYAML library. Now we are going to actually deploy our serverless function. So I'm going to say SLS deploy. Now this is going to create an API gateway endpoint, and it's also going to create a S3 bucket for the deployment. It's also going to load the function and hook everything up to ensure that we can start interacting with this function as a REST API. So I'm going to fast forward through this segment of the video because it's going to take a little bit of time for us to deploy this particular function. Now we are done deploying the function, and you can see that we have an endpoint, an API gateway endpoint that is generated, that we can start interacting. We can start uploading our YAML to this, and it will process just as the function has been created to process that. So now let's actually upload a YAML to this function and actually test it out and see what you can do. Now, remember, we already have our secret key, just making sure that we have our secret key still loaded, because this secret key is injected to the server-side environment as an environment variable as well, just to add an additional layer of access control in case somebody forgets to disable this lab later. So that's one of the reasons why we actually added that secret key. So if you look at this, we're going to upload our payment file. This is just a simulation of a payment YAML file. So imagine that you are posting a payment to a particular site, and it has some attributes like the name, the merchant, the amount, the card number, or something like that. However, in the reason you will see something very dangerous here, which is our Python object code, which is attempting or trying to get the backend YAML library to recognize this as a Python source code and or run this particular module subprocess and run this particular function check output, which is actually going to run this command print env on the back-end operating system, which is very, very dangerous. If we are able to do that, we are able to essentially run remote code in that Lambda environment, because we are able to run our code in that back-end Lambda function environment, which is obviously very dangerous. So since we have deployed this, let's start to actually make that. So I'm going to copy this URL, and you can copy this, and I'm just going to clear screen, and I'm going to make a HTTP post /YAML upload. I'm going to add an authorization secret key. This is a header that I'm adding. And I'm going to upload this file, which is test_payment.yaml. So now this should be uploaded to the server side, which is going to be processed by the function. It's going to unwrap this YAML and then try and parse the YAML. And during the parse is when it triggers the deserialization flaw, and then should execute that command print env. Let's see what print env gives us. So when we do this, it processes it, and you see that the reason comes back with a pretty large base64 data set. So if you see that what is happening, it's parsed and it just encodes it in base64. So let's just copy this string, open up a new file, and so I might have to remove the new line character. So just to remove the new line encoding that the IDE just adds, that's why I'm just doing it this way. So if I do this, echo whatever base64 value we have, and if we do base64-d, you will see that all the environment variables from the backend function environment have now been dumped on screen. So you see that the print env gives us access to all the environment variables that have been loaded in that Lambda function execution environment, which in this case has the token injected. Remember that Lambda function has a bunch of privileges that requires tokens to be injected into the function so that it can access all of these privileges. And these privileges mean I can do anything to logs, I can do anything to EC2, I can do anything to S3, which means that it's got a lot of privileges. And this token is going to last for at least, I think, 6 to 12 hours. I'm not exactly sure about the time that this token will last, but it actually lasts for beyond the Lambda function itself. So even though the Lambda function is actually executed, and even if the container or the function is currently in cold storage, this still works. Right? You still see that the secret key, the session token still works. Now I can use these session tokens. I can use the secret key, the session token, and the AWS access key to be able to actually access my AWS environment and then compromise based on that privilege. So now all I have to do, so let's copy these values. I'm just going to copy these values, which are useful to me for starting my privilege escalation. And I need my session token as well. Just copying all the values that I need. Again, just making sure that I remove the new line encoding from that AWS session token. Now I can just do this. Now I'm going to be accessing my AWS. I'm going to try and access my AWS account as this particular role. So I'm going to try and impersonate the function's role as an AWS user, and I'm going to start accessing as the function, which means that imagine if it was some third-party attacker, that third-party attacker would pretty much be able to access your AWS environment now as the Lambda function with the Lambda function's privilege, because that person has access to the access key, the session token, and so on. They're able to impersonate the Lambda function and gain access to everything that the Lambda function has access to in this case, which is quite a lot because the IAM privileges have been very badly created. So if I actually do this, if I do export this, I'm just going to add exports, I'm just going to copy paste the exports and the session token. So now if I do AWS STS get caller identity, This is going to essentially tell me who's the AWS account or which is the AWS role that is making this call. So it's actually going to give me an idea about which is the role that's making this call, and you'll see that this is the role that has been attached to that function that we just created, the deserialization function. The user ID is that temporary credential that has been granted to that function, and it gives me the account and all of that stuff. Now I can start to escalate privileges. I can start to do AWS S3LS because I have access to S3. I can start accessing all my S3 resources and start stealing stuff. I can even launch EC servers. I can pretty much control your entire AWS account from this point on, because that is what this privilege or this role has allowed me to do. So this role has a set of policies that allows me to do that. In this case, you can see that it allows me to do all these things. I can pretty much do all of these things against all resources on that particular AWS account, which is really, really dangerous. So even in a Lambda function, remember that a Lambda function, if you have remote code execution on a Lambda function, the attacker can use the environment variables. If the attacker is able to leverage the environment variables or gain access to environment variables, the attacker can use those compromised environment variables to start escalating privileges to your AWS account, given the amount of privilege that Lambda function has. So if that Lambda function has a lot of privileges, which a lot of them still do, you will see that you can gain access to a lot of privilege functionality within that AWS account and completely compromise it. So this, as you can see, is a very dangerous attack. If you liked that video, you should consider liking and subscribing to our YouTube channel. Follow us on LinkedIn and Twitter. And if you want the best quality education for AppSec, cloud native security, Kubernetes, DevSecOps, threat modeling, and a constantly updated library of amazing courses with amazing hands-on labs, you should get a subscription for AppSecEngineer.com. Subscriptions are available for both individuals and teams of any size that you can access on AppSecEngineer.com. Please check us out.